Well, we have like question 2 here. The question says, given the finite arithmetic sequence, okay, this one, and in the previous videos we did question 2.1 through question 2.2, 2.3. Now we're going to do question 2.4. The question says, consider the sequence 5, 1, -3 to -83 and -87 through -4187. Determine the number of terms in this sequence that will be exactly divisible by 5. Okay, let's say these are the sequence here. Excuse me. Now, we need to determine only the number of the terms that are multiple of 5. So there are some terms here in this sequence, in between here, in the dots here, that will be multiple of 5. Now, how many of them are? That's what the question is. That's what the question is. Now, first, I'm gonna write what we find in the previous video. We did find that Tn was formed by -4n plus excuse me, -4n plus 9. Now we can notice that the first term here is a multiple of 5 already. Now, if I write here if n is equal to 1, if n equal 1, T1 will be 5. Now let's check again. Now we're gonna go through some trial and error. Okay. We can use a calculator to see. Okay, because we have like -4 plus, okay, -4n. So I'm gonna leave brackets here plus 9. Now we want to do some trial and error to see the terms, at least few terms that are multiple of 5, if there is a pattern in the terms. Okay, if n is equal to 2, for instance, we can see that this is 1. But yeah, I cannot take 2 because here it's 1, and I know term 3 is also -3, so I don't need to check for those. So now I'm gonna take like term 4. I want, because we also calculated that in the previous video. Let's take term 5. It gives me 11. Okay, let me see. Term 6, how much? It's gonna give me -15. So if n equal to 6, we have like T6 will be -15, which is a multiple of 5 also. I'm gonna check again for another value of n. When I sub in the value for n, if I sub the value like 7, I guess it won't work. And then if I sub another value for n, it's not giving me what I want. 9, if I sub 9 there, neither. If I sub in 10, 10, nope, obviously not. But let's see 11 then. 11, if I sub in 11, et voilà, 11, term 11, is equal to -35. Now, I noticed two things here. There is a pattern here, and there is a pattern there also. Okay, let's first look at in this pattern, where we have like 5, so like 5, -15, -20, -35. This is a pattern because these terms forming also a constant difference of -20 So if it forms a constant difference, we can also create a formula for those terms that are multiple of 5. Okay, we can just write the constant difference, which is -20 n. Okay, and then we say to ourselves if we need how much do we need to add into -20 to get 5. So we add 25. Okay, 25. So this is actually the formula. We can also use the same formula by using Tn equal to, it's the same thing, Tn equal to A plus n minus 1 times t. We're gonna get the same answer as here. So let's just go this way, show Tn will be equal to the first term is 5, and then n minus 1 times the constant difference is -20. So if we times, we will get this. Then if it is so, we then want to find also another term over here. Okay. Okay, as I was saying, we need to find then, because this last term here is not a multiple of 5 because it ends with 7. So it must be a number that ends with 5. How can we get it then? How do we know? Do we have to do trial and error all the way to get this number? I don't think so. It's going to be a lot of work. But we can just work out, we do know that Sn is equal to n over 2 over here's 2a plus n minus 1 times d. Okay, and then we also do know that Tn is a plus okay, I prefer to do this. Okay, I want to say over here, because we already write Tn here, it must be a term that must be less than negative 4,187. Okay, so now we just gonna do negative 20 n plus 25 lesser than, we need to find which term is that, okay, lesser than negative 4,187. If I move the 25 over, that makes negative 20n will be lesser than negative 4,187 minus 25. So this makes negative 20n will be lesser than, we can use a calculator for that. This will be negative 4,187 minus 25. Okay, this is equal to negative 4,212. Okay, so if we divide by 20 both sides, we divide by negative 20, divide by negative 20, and then we will get n must be lesser than this divided by 20, lesser than, if I press here, negative, okay, so I'm now positive because we divide by negative 20. That makes positive 210,6. Okay, because positive here. Therefore, we can say, okay, the number of the terms must be n equal to 210. Thank you.